So you have to start first, no? Is starting? Yes. So yeah. So dear friends, today we are discussing about the physics topic, current electricity. So first, in this topic, we are going to learn about the electric current. So the electric current is flow of charge in any cross section of conductor in 1 second. So the current can be represented as I, charge represented by Q, time represented by T. So rate of flow of charge is called electric current, and also we can current written as I is equal to dq by dt, because rate of flow of charge changes with the time. Now we are going to learn about different type of currents. Here there are the three type of current: steady current, varying current, and alternate current, that is called as AC current. AC means alternate current. So first is about steady current, the current which does not change with the time. So this is blue color is shows about steady current. The second is about varying current, whose magnitude is vary with the time. So here this is, yes, varying current. So here that current is vary with the time. And the last one is about the alternate current. Alternate current is one whose magnitude change continuously and whose direction is changed periodically, that is called as the alternate current. So the alternate current whose magnitude vary continuously and the direction change periodically. So this is the sinusoidal waves. Here this is along y-axis we are taken as I, along x-axis we are taken as t. So this sinusoidal waves is called as alternate current. So alternate current is the current whose magnitude varies continuously and the direction is changed periodically. That current is called AC. In India, the voltage of AC is 220 and the frequency is 50 Hertz. So the current in alternate current in India change within a second 100 times. So we discuss about three type of current: steady current, varying current, and alternate current. Now move ahead. Now we are going to discuss about the conventional current. So my dear friends, this is the metal. Metal is a conductor, and the pen plastic, that is an insulator. The substance is conductor because current is passed. The substance is insulator because current is not passed. The metal we are coating with the plastic because we are not feeling the shock, that is insulator. Insulator is a substance which not allow the current to pass. So current means charge. So who is moving? Suppose if we are discussing about the atom, the central is the nucleus in which proton and neutron is there in a orbit, electron or revolve. So now my dear friends, proton is positive charge, electron is negative charge, and neutron is neutral. So the J.J. Thomson discovered the electron, Rutherford discovered the proton, James Chadwick discovered the neutron. When electron was not discovered, the current is showing that in a circuit we are telling that the direction of conventional current is from positive to negative. One question is the proton is moving? Proton is not moving. Who is moving in a conductor? The valence electron. Why the metal is conductor? Why the plastic is insulator? Because metal have valence electron. So electron is moving in conductor. So the when electron was not discovered, the scientists give the direction for conventional current is from positive to negative. The direction of motion of positive charge under the action of field is considered as direction of current. But electronic current flow from negative to positive. Conventional current flow from positive to negative. Both are in opposite. If we take a cell, there is a charge is there. If we take a battery, there is a charge is there. So if we are giving the connection in a circuit, conventionally, how the electrons are moving in a same direction with the conventional current or in opposite direction? The electron move in opposite direction of flow of charge. Electron move opposite in direction opposite to the motion of this electron is moving opposite to the conventional current. So now next about the drift velocity. When the electrons are there in a conductor, we are supplying the current. So here Vd is nothing but drift velocity. A is acceleration, T is relaxation time, E is representing electric field. Capital E is electric field, small e is electronic charge. Charge of electron, that is 1.6 into 10 to the power of minus 19 coulomb. M is mass of electron, N is number of density of electron, L is length of a conductor, A is area of conductor. These are the factors, these are the terminology we are using here. So now, what do you mean by drift velocity? The electron will not move itself. We have to do the work. We have to move the electron. So what do you mean by drift velocity? The velocity with which the free electron get moved towards the positive terminal by the action of electric field. That is called as drift velocity. That is represented by Vd. That is equal to A into T acceleration, and it is relaxation time. That is equal to NA8Vd. So here number of electrons, charge on electron, area and drift velocity. So current is represented by this formula. So my dear friends, current is directly proportional to drift velocity. So now move ahead. We are going to discuss about the current density. Current density represented by J, that is explained by the current per unit area. The current per unit area in a conductor is called as current density, and in vector form that can be written as Ij dot product of area. Now we are going to learn about the Ohm's law. That is, the scientist's name is George Simon Ohm. What is the name of the scientist? George Simon Ohm. In the year 1827, he explained about the relationship between voltage and current, and he explained about the law that is called as Ohm's law. It is very easy and easy to understand. If we are seeing the bulb, if the voltage is increases, naturally brightness is increases, current also increases. So the George Simon Ohm in year 1827 explained about the law that is called Ohm's law. Ohm's law is nothing but the current flow in a conductor is directly proportional to potential difference across the end of a conductor. So current is directly proportional to voltage, voltage is directly proportional to the current. But physical condition, temperature, mechanical strain, other is remains same. There we are not changing the temperature. If changing the temperature, there is a variation of current and voltage will be there. So I proportional to V, V proportional to I. So remove the proportionality, we are taking the R, that R is called as resistance. What is R, my dear friends? It is resistance. It is, what is resistance? Resistance is opposition to flow of charge. Resistance means opposition to flow of charge. That is called as resistance. The SI unit of resistance is ohm. That is represented by the symbol this one. So that Ohm's law represented by graph. This is x-axis we are taken as voltage, along y-axis we are taken as current. So we are getting the straight line. This shows that the straight line shows that there is a variation of voltage along with the current, and it is ohmic conductor. If a line is curved, that is called non-ohmic conductor. Hope my dear friends you understand this. Let's move ahead, go for the next topic. Now we are going to discuss about the resistance. The symbol of resistance is, this is the symbol of resistance. Resistance of a conductor is opposition offered by a conductor to flow of electric current. So one simple question is there. If there is a resistance increase in a conductor, so what will happen to current? If this value is increases, current value will become decreases. So resistance is inversely proportional to the current and voltage. So R is representing resistance, V is the voltage, I is the current, this is the Ohm's law. Now about the here the resistance, this is called, symbol is rho, that is showing about resistivity. So resistivity can also be written as that cross multiplication Ra divided by L. So what do you mean by resistivity? That represented by the symbol that is read as rho. So resistivity is a resistance of a conductor of unit length and unit area. That is called as resistivity. Resistivity not depend upon length and area, but resistance depend upon length, area, temperature and nature of material. So here my dear friends, resistance is directly proportional to the length, inversely proportional to the area and depend upon nature of material. What does it mean? If the area of, if the area is, if the length is increases, so the collision between the electron increases. As length increases, resistance increases. Now if national highway, there is two-way, three-ways is there, easily vehicle is passed like that. If area of conductor increases, easily charge is passing, area is increases, resistance decreases. Hope you understand this concept. So my dear friends, resistivity depend upon nature of material and temperature, but not depend upon geometrical dimension, upon length and area resistivity is not depend. So now my dear friends, current that we are writing this formula, this and resistance we are representing, we can represent by the this formula here. Mass, this is the number of electrons, charge on electrons, relaxation time, current, this formula is there, you have to remember. Hope you understand this. Now move ahead for the next topic about relation between drift velocity, resistivity, current. This is energy, that is, and about the voltage and about the current density. So let's see here, when the temperature is increases, there is a more collision between the electron, so it is difficult for the electron to move. Drift velocity decreases, resistivity increases. When current is increases, drift velocity decreases. These points you have to remember. So the current density is nothing but current per unit area, and resistivity, that we are writing this formula, and that is about the drift velocity. Now move ahead about the opposite of resistance is conductance. Opposite of resistivity is conductivity. What do you mean by conductance? Resistance is opposition to flow of charge. So what will be the value of, what will the meaning of the conductance? Yes, very good. It is reciprocal of resistance. What is the SI unit of resistance? Resistance is ohm. Now conductance is reverse, MHO. Now conductivity is opposite to the resistivity. Reciprocal of resistivity, that is called conductivity. The unit is MHO, that M. So now next learn about temperature dependence of resistance. As I have told you students, if the temperature is more, the number of collision among the electrons is increases. Due to the more internal energy, relaxation time will less, so resistance is increases. Resistance is directly proportional to temperature. Because of more collision, more internal energy, less relaxation time, so resistance increases. So now here, that is the formula mentioned here, resistance. Now temperature coefficient of resistance. This alpha telling about temperature coefficient of resistance. R2 minus R1, R1 T2 minus R2 T1. So here R naught is resistance at zero temperature, RT is resistance at T temperature, R1 is resistance at T1 temperature, R2 is resistance at T2 temperature, T1 and T2 temperature. If R1 is lesser than R2 is lesser than R1, this alpha is negative. Now come to the point of color code for resistance. So students, resistance is a fixed value. There are some colors on the resistor that shows the value of the resistance. It is the fixed value, but one resistor is there, that is the variable resistor, that is the rheostat. But see here my friends, this is the carbon resistor that having the four colors. First two colors are telling about the number, maybe 1, 2, 3, any number. Second color is tell about the multiplier of 10. The fourth color is telling about tolerance. Might be gold, silver or no color. So how we can find out the value of resistance? By seeing the colors. So simple formula is there, that is sentence is there, very easy sentence my dear friend, easily you can remember this to the colors and numbers. That sentence is nothing but B.B. Roy of Great Britain has very good wife. So here BB Roy, BB Roy. So how many colors? 5 colors. Great Britain, very good wife. So it is BB Roy. Great Britain have very good wife. So B is black. Second B is brown. R is red. O is orange, yellow, green, blue, violet, grey, white. So starting with the 0, there are the 9 numbers are there. Black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, grey is 8, white is 9. This number we have to remember, and this colors and with the values. Second is fourth is about telling about the tolerance. These 3 colors, this is the fourth number about the tolerance. If golden is there, it is 5% tolerance. Silver is there, it is 10% tolerance. No color is there. If fourth color, no color is there, it is 20% tolerance. So now see here students, first 2 colors telling about the indicating first 2 rings. There are total 4 rings in a resistor. First 2 rings from the end gives the 2 significant figures of resistance in ohm. These 2 colors, 2 rings telling about the 2 significant figure. The third one colors telling third ring, third color indicate decimal multiplier. That is decimal multiplier 10 to the powers they are indicating. The last ring telling about the tolerance in percentage. So now see here, see this is first color is, it is brown color, so it value is 1. Second color is violet color number is 7. The third color is black color, that is 10 to the power, that black color is 0. Any power is 0 means 1. So it is 17 ohm. And this is the golden color tolerance. The tolerance is 5%. So plus or minus 5% ohm. The value of this resistor is 17 ohm. Now let's see what is the value of this resistor. Green color. My dear friends, what is the value of green color? See here, where is the green? This is the green color. Its value is 5. Green color number is 5. Red color number is 2. So it is 52. 2 rings telling about the 2 significant figure. The third ring tell about the multiplier. It is blue. Blue is about 6. So it is 10 to the power of 6. And the fourth ring is about the silver, so it is tolerance is 10%. So this value is 52 into 10 to the power of 6 plus or minus 10 24 10% ohm. This is the value of second resistor. Now go for the third color. The first is about brown, that value is 5. Violet, that we hear about the, so here is brown. Brown is, this is number is little change. Brown is, dear students, brown is 1. Violet is 7. Black is 0. This is 10 to the power of 0. So this is the value. Little bit correction is here. So like that we can find out the value of the resistors. Now here we are discussing about connection of resistance. Here R1, R2, R3, there are 3 resistance: positive, negative, positive, negative, positive, negative. Positive of one terminal connected to the negative, end to end connection. End-to-end connection of resistors is called as series combination. Positive of one terminal of a resistor connected to negative of second one. This type of connection of resistor is called as series combination of resistor. The effective equivalent total resistance of resistor are connected in series is equal to sum of the individual resistance, that is R1, R2 plus R3. Here the total resistance, equivalent resistance, effective resistance is greater than the greatest of all the resistance. Now hope you understand this, my friends. Now how many resistors are here? There are three resistors, all plus connected to the one terminal, all the minus connected to the another terminal. This connection of resistance is called as parallel connection. This is just like a train, any wagon we are joining. This is parallel connection. The benefit of parallel connection is if one wire is cut, other wire will work. So the total resistance, equivalent resistance, effective resistance in parallel is formula is 1 upon R, 1 upon R1, 1 upon R2, 1 upon R3. So here the total resistance in parallel combination is smaller than the smallest of all resistance. So when we are connecting the resistance, total resistance in parallel is less, the more resistance is there in series. So one simple question is there: in house, offices, factory, industry, the electrician giving many connection to the fridge, cooler, washing machine, so many gadget device we are connecting. So my dear friends, the question is it good to give the connection to the gadget series or in parallel? So the domestic circuit, the better connection for all that is parallel combination of resistance. Hope you understand this topic. So my dear friends, hope everybody is well, understand this one. So my dear friends, thank you for using, cooperating and using the Raman tutorial for GK. So next we move ahead for the next topic about the source of EMF. EMF is electromotive force. My dear friends, is this a force? EMF, is this a force? No, not at all. It is not a force. Electromotive force is maximum potential difference between the electrodes of a cell when no current is drawn from the cell. Cell is the source of DC current that convert chemical energy into electrical energy, that is the direct current. So electromotive force is the maximum potential difference between the two electrodes, positive and negative electrodes of a battery, when no current is drawn from the cell, so it is in switch off condition. So now my dear friends, let's discuss about what is the difference between electromotive force and potential difference or voltage. Both are same or both are change. What is potential difference? What is the difference between EMF and potential difference? So first is EMF, electromotive force, is the maximum potential difference between the electrodes of a cell when no current is drawn from the cell. The circuit is open, the current is passed only when the circuit is closed, that is on. The maximum potential difference between the electrode when no current is passed, that is circuit is open, that is called as a maximum potential between the electrode when the circuit is open, no current is passed, that maximum potential difference is called as electromotive force. Now what do you mean by potential difference or voltage? Potential difference or voltage can be written as W by Q. It is amount of work done to move a charge from one point to another point, and also it is called as the difference of potential any 2 points in a closed circuit. Here is an open circuit, here is a closed circuit. Next, it is independent of resistance of a circuit. It is proportional to resistance between the given points. EMF is used only for source of EMF. It is measured between 2 points of a circuit. Now, the greater is the potential difference between any 2 points in a circuit, the potential difference is greater than EMF when cell is being charged. So my dear friends, hope you understand. Now go for the, we are going to learn about the next topic about internal resistance of a cell. There is a resistance to the flow of charge externally, because of that current will be the less. But as far as cell is concerned, by the electrolyte, the cell generate the current by the chemical energy. There is a resistance inside the cell. The opposition offered by electrolyte, the solution, the chemicals of a cell to flow of electric current is called as internal resistance. This is represented by small r. The resistor that is represented by capital R. So what is the factor on which internal resistance of a cell depend? So now see here, in a cell there is a electrode suppression is there. So what are the, how many electrode are there in a cell? Two electrode, positive electrode, negative electrode is there. Larger the separation between the electrode of the cell, the length will be more length. So what happened to the current? The current has to flow higher value of the internal resistance when the gap between the electrode is more. The greater the conductivity of electrode, at the time internal resistance will be more or internal resistance will be less. My dear friends, as the conductivity is increases, internal resistance will be decreases. So internal resistance is inversely proportional to, area of electrode in a electrolyte. As as the area of electrode is increases, the internal resistance will be decreases. Hope you understand this. Now move for the next topic about the, here it is EMF, it is voltage, and it is V, capital V, small v. So Ohm's law, V is equal to IR, V is equal to internal resistance. So here common is I, R plus R. So I is equal to, this will goes to denominator. So I is equal to E upon R plus R. So this relation is called as circuit equation. So my dear friends, what is this capital R represent? Resistor. What is this small r represent? Internal resistor. What is V? It is voltage. What is E? It is EMF, electromotive force. Now see here, internal resistance of a cell in term of EMF, voltage and resistance. This is the formula if we simplify this. So internal resistance of a cell, there is a external resistor in a circuit, there is a internal resistance present in a cell. So the internal resistance can be written as equal to electromotive force upon voltage minus 1 into R. E is EMF, V is voltage, R is resistance. So small r is telling about internal resistance of cell. Now determination of internal resistance of a cell by voltmeter method. What do you mean by voltmeter? SI unit of potential difference is volt. Voltmeter is a device that measures the voltage. So determination of internal resistance of a cell by voltmeter method. So here we are having the internal resistance voltmeter connected with parallel, the battery, the resistance box, the key, open circuit, no current is drawn. We want to measure the EMF. When circuit is closed, current is passed, we are measuring potential difference. So just I have told you the difference between electromotive force and potential difference. Potential difference is the difference between the two terminal when the current is passed, when the circuit is closed in on form. When the circuit is closed, no current is circuit is open, no current is passed. At the time, are we measuring the potential difference or are we measuring the electromotive force? At the time when circuit is open, no current is passed, we are measuring EMF represented by capital E, that is electromotive force. So hope you understand. Now move ahead the topic cell in series combination. Now my dear friends, when current is not there in office, bank or anywhere, at the time we are using inverter, generator or we are using the battery. So what do you mean by battery? So this is long terminal, small terminal and the group of cell is called battery. As earlier we have learned that resistance are connected. So cells also connected. The group of cell is called battery. Group of cells is called battery. So now we are going to connect the cell. One, two, three. So now we are learning about the combination of cells. There are two type of connection of cells. One is in series, another is in parallel. What do you mean by cells in series? Cells are connected in series when they are joined end to end. End of a one battery to the another one cell another. If you take a torch, you are joining the cell. If you take a battery, there are many cells are there inside the battery. That each cell produce the voltage, the sum of will be there, and that will be the huge voltage will become. In a battery, many cells are there, many columns are there. So end to end connection of a cell is called as cell in series, so that the same quantity of current must be flow through a each cell. Now EMF of a battery is sum of individual EMF. The current in each cell is same and identical with the current entire arrangement. The total internal resistance of a battery is the sum of internal resistance. So now my dear friends, tell me how many cells are there? There are three cells. How they are connected? They are connected in series. Why we are telling that they are in series? Because they are connected end to end. What is the R represent here? Internal resistance. What is E represent? Electromotive force. What is this R? External resistance. What is V? It is voltage. Now the total EMF of a battery is Ne and total internal resistance is Nr. The total resistance of a circuit is N internal resistance plus R. N is number of cells. So now see here the current is number of cell electromotive force N small r plus R, that is the formula for current, and that when the cells are connected in series, the conclusion is there. When internal resistance is very small, when the internal resistance of a cell is very small, negligible compared to the external resistance, the cells are connected in series to get the maximum current. Here, my dear friends, we are connected the cell in series. The cell have the internal resistance. In a circuit, there is an external resistance. When the internal resistance of a cell, when the internal resistance of a cell is negligible, very small value as compared to external resistance, the cells are said to be in series, connected in series, and we are getting minimum current or maximum current. We are getting maximum current. So let's move ahead. The another type of connection of cells. All the positive terminal of a cells connected to the one side, all the negative terminal of a cell connected to the one side. They cells have the internal resistance, electromotive force. R is external, that is the resistance. This is the voltage. So now, what do you mean by cells in parallel connection? How we have to join the cell? We should tell that they are in parallel. So when all the positive terminal of a cell join to the positive, all the negative of a battery connected to the negative, such that current is divided between the cells. This connection is called as cells in parallel. Hope my dear friends you understand this. So the points regarding the cells in combination, parallel combinations, EMF of a battery is same as that of a single cell. The current in an external circuit divided equally among the cell. The reciprocal of internal resistance is sum of reciprocal of internal resistance. The total EMF of a battery is represented by capital E. The total internal resistance of a battery is represented by internal resistance by N, number of cells. The total resistance of a circuit is internal resistance, number of cell plus external resistance. So here in a parallel, the current can be represented as number of cells electromotive force upon number of cell external resistance plus internal resistance. So that let's see the conclusion of cells are connected in parallel. When the external resistance is negligible, when the external resistance of cell connected in parallel is negligible comparing to the internal resistance of a cell, then the cell are said to be are connected in parallel. So now we are getting the maximum current when they are connected in parallel. Hope you understand this. So my dear friends, so we'll continue. We'll discuss about, now we are to discuss about the second topic about the current electricity, about Kirchhoff's laws of electricity, Wheatstone bridge, meter bridge, potentiometer, principal comparison of EMF. So first we have to discuss about the Kirchhoff law. Kirchhoff is a name of scientist. Who is Kirchhoff? Is a name of scientist. He explained about the two current law. One is called as Kirchhoff current law, another is called as Kirchhoff voltage law. Kirchhoff is a scientist who explained the two laws regarding about the current and voltage. First law is called as KCL, second law is called as KVL. Kirchhoff current law, Kirchhoff voltage law, or it is also called as junction law, and the second is called as loop law. What do you mean by Kirchhoff current law? So now see here students. First you try to see about the arrow. When the current is coming, current is incoming towards the junction, that current is taken as positive. When the current is leaving toward the junction, entering to the junction taken as positive. When the current is outgoing from the junction taken as negative. So the Kirchhoff first law telling about that the algebraic sum of current at the junction, algebraic sum of electric current at a junction in any electrical network is zero. What does it mean? Whatever amount of current is entering, the same amount of current is exiting. So what will be the total current at the network? That will be zero. The algebraic sum of electric current at a junction in any electrical network is zero because the incoming current is equal to outgoing current. Incoming current toward the junction is taken as positive and outgoing is taken as negative. Here I1 and I4 are incoming, so they are taken as positive. I2, I3, I5 they are minus. So sum of this answer result is zero. So the algebraic sum of current at a junction in any network thus is zero. This is called as junction rule. This is called Kirchhoff first law, Kirchhoff current law because it was explained and discovered by Kirchhoff. Now move for the second law. It is called Kirchhoff voltage law. The simplest answer is algebraic sum of voltage or potential drop across the network is equal to zero. The Kirchhoff voltage law telling about that the algebraic sum of potential drop at any closed network is equal to zero. So my dear friends, see here we are using here two cells connected with the three resistor. They are making the closed path. This is the electrical network. So here battery supply the EMF. So EMF is taken negative when the current is transferred from positive to negative. The EMF is taken as positive when EMF is transfers from negative to positive terminal of cell through the electrodes. So A B C D, see A B C D here ABCA1 network, here is ACDA, this is the another network. So they are telling that algebraic sum of potential difference, potential drop along any closed path. It is open path, closed path, it is closed path. In an electric network is zero. This is called as Kirchhoff's second law, voltage law, or it is called as loop law. In first, algebraic sum of current is zero at a junction, but here algebraic sum of potential difference along any closed path in an electric network is zero. So hope my dear friends you understand this. Now move ahead. So potential fall along the direction of current in a path. It rises along the direction opposite to the path. Potential fall taken as negative, potential rise taken as positive. The path can be traversed in clockwise or anti-clockwise. It depends upon us. We can take it is clockwise or it is anti-clockwise. But sum of the voltage in a network is zero. Now move ahead students. It is Wheatstone bridge. Why it is called Wheatstone bridge? Because it was discovered by the scientist Wheatstone. So in Wheatstone bridge, how many resistance we are using? We are using 4 resistance P, Q, R, S. We are using 4 resistance. And Here, students, this is the Wheatstone bridge. At the center, this we are connecting the galvanometer. The Wheatstone bridge is said to be balanced when is no current is passed in a galvanometer. The potential difference between these 2 points is become zero. When do we say that Wheatstone bridge is balanced? When is zero current is passed in a galvanometer. When the no current is passed in a galvanometer, the potential difference between BD points becomes zero. So the Wheatstone bridge is said to be balanced when P by Q equal to R by S. This is the ratio of four resistors P upon Q R upon S. When Wheatstone bridge is said to be balanced, no current is passed from the galvanometer. At this end, potential difference is zero. When the potential difference is no potential difference, current will not pass. Without potential difference, current is not passed. So Ig, current in galvanometer is zero. The Wheatstone bridge is said to be balanced. So now move ahead. Let's discuss about the meter bridge. Why it is called meter bridge? Because here 1 meter scale we are using here. On which principle Wheatstone bridges work? Uh, on which principle meter bridges work? Meter bridges work on the principle of Wheatstone bridge. So now the meter bridge is used to find out the unknown resistance. Why we are using meter bridge? To find out the unknown resistance. This is the resistance box. This is the resistor. This is the value we know. We want to find out the unknown resistance. This is the diagram is called meter bridge. Here we are using resistance box. Here we are using unknown resistance. This is the galvanometer. Galvanometer is attached with the J, that is called as jockey. When the jockey is moved on a line, this line, that length 100 centimeter wire is there, 1 meter wire is there. For a particular position on a wire, the galvanometer show the zero deflection. By the finding the zero deflection, finding the length, moving the jockey on a meter bridge, we can find out the unknown resistance. The meter bridge work on principle of Wheatstone bridge. So by the formula X is equal to R 100 minus L divided by L, by using this formula, by using the meter bridge, my dear friends, we can find out the value of unknown resistance. By resistance box, we knew the value of R. By null deflection, zero deflection, we can find out the value of L. So remaining will become 100 minus L. Putting these values, the resistance we are applying in a resistance box, the length of a wire well there is shows a zero deflection. So the resistance in a wire is proportional to the length of a wire. So by this equation, my dear friends, we can find out the unknown resistance. Now move ahead. The device that is called as potentiometer. This potentiometer having 400 centimeter wires, 4 meter wires, 1 meter, 2 meter, 3 meter, 4 meter wires. So we have the voltmeter to measure the voltage. Why do we need to use the potentiometer? Potentiometer is a device work on the null effects. No current is passed. Potentiometer is a ideal voltmeter that is used to measure the potential difference. or comparing the EMF of a cells. This is the diagram of potentiometer. This is our voltmeter connected to the jockey. This is our EMF. This is our ammeter. This is our rheostat. Change the resistance. This is our key. These are our wires. That conductor is there. Their length is in centimeter. 1 meter, 2 meter, 3 meter, 4 meter length is there. 400 centimeter. So we are moving the jockey on the wire. We are finding the null deflection where the point, the galvanometer, voltmeter not show the deflection. That point we are indicating. With the help of this, we can find out the potential difference, or we can find out the comparing the EMF. Now, if the constant current flow through the potentiometer wire of uniform area and composition of material, so voltage is proportional to the current. V by I is constant. So potential difference across line uniform composition is proportional to the length. The potential difference across any length is proportional to the length when the constant current is flowing in it. So this is the diagram. Here we are using the two cell Leclanchian cell and Daniell cell. We are comparing the EMF of a cells. By using the potentiometer, my dear friends, we can compare the EMF. Two cells are there. Externally, we are supplying the voltage. We have the 4-meter wire. We have the two cells. Their EMF we are comparing. We are using the resistance box to fixed resistor value. By the galvanometer, jockey is there. The jockey is moving on the wire. We are finding the null deflection. With the help of this, we can find out the length, and by simplifying this, E1 upon E2, I1 upon I2. By this equation, we can compare the EMF by using the potentiometer. It is a device which is the ideal voltmeter that can be measured the potential difference, work on the null effect, or the balance point is obtained when the cell for the cell when potential at a point on a potentiometer wire is equal and opposite to the EMF of a cell. So see here, the balance point will not be obtained on potentiometer wire if fall of potential along the potentiometer wire is less than the EMF of a cell. The working of potentiometer is based on which deflection? Null deflection methods. So the resistance of a wire become infinite. So the potentiometer can be regarded as ideal voltmeter. So my dear friends, these are the things today we have completed. Hope you understand this. So thank you very much, my dear friends. Seeing helping to the using the Raman tutorial, cooperating the Raman tutorial. So in this today topic, we have completed about the electricity difference topic. Any kind of doubt if you are having, we are ready to help you. The teachers wish you all the best for your government selection jobs. Prepared well for the GK paper, for the mental ability, for the general English, general knowledge, or your subject. Prepared well. We are ready to help you. Hope all my friends will get the government seat with above cutoff. So thank you once again for the teachers, everyone who supported us for this. So dear friends, thank you very much. Thank you.